for joining. So next session is by Dario. He's product manager at Oracle. He's from France, and I let you start. Thank you for joining.
Hello, good morning, ciao, on the bonjour so community. Very glad to be here today to share about Oracle NoSQL Database. So a few words about me. So as already said, I am product manager in the data management team. My passions are cloud, are SQL database, and of course, NoSQL databases. I am free or share, so if you want to discuss with me, so please contact me by LinkedIn or directly by mail, dario.vega@oracle.com. So a few days ago, we released our Oracle NoSQL Database version 21.1. This is our 10 years birthday release. This is why the title of this meeting, okay? This meeting is very simple. We will talk about Oracle NoSQL at Oracle. This is a technical session. You don't need to be an expert in NoSQL solution. It was designed for developers, architects, and administrators. If you want to discuss about use cases, to have a demo or have a meeting about the discussion, how to choose between a NoSQL or not or SQL database, just let us know. We will be very happy to organize a new session with the SOA team. Okay, this is my agenda. This presentation was initially designed for 45 minutes and 60 minutes. Okay, so let me explain the agenda. So the first thing is, that is the goal of this meeting. If you have time to see the abstract, that is a copy paste from the abstract. What is important here is latency response. We will see this in the technical architecture. Elastic scaling, we will see in the technical architecture. Flexible data models, we will see in the application development part. And how I decide this agenda. So in order to do this, I think about the most frequent question that I have from my customer when I am discussing about Oracle NoSQL database. The first question is it a shared and nothing distributed database? The answer is yes. We will see this in the technical architecture. How do you address horizontal scaling availability? We will see also at the technical architecture. Is it a key value, or a document, or columnar, or a graph database? We will see this in application development. We will see the next question is, this is a multi-model database, because the flexible data models, we will clearly see this in the application development. Then, what are the deployment options? We will see this in the second part of the agenda. Is there a managed service in the cloud? We will do a little focus at the end of this meeting in the cloud service. What about the CAP theorem, Brewer's theorem, Pascal, base philosophy? We will see this in the technical architecture. What kind of API do you have? We will see this in the application development. And what about the query language? Of course, in the application development. The first part is a retrospective because this is our 10 years anniversary. And when discussing with my customers or friends or peers or partners, this is not the same thing to discuss about Oracle NoSQL in 2010, Oracle NoSQL in 2000, or NoSQL in 2015, or in 2020. Okay, so the main idea is to see what is the journey and try to understand how our product is evolving and what is the direction that we are providing. Okay, this retrospective will take 5 minutes. Don't worry about this. It's only 2 slides. Okay. So first, in 2010, the project is we start to create an scalable key value database powered by Berkeley DB. Okay. In 2020, our focus is Oracle NoSQL Database Cloud Service. It doesn't mean that we are not working anymore in the software product. Of course that we are working in the software product, to improve our cloud service, we need to improve our product, so Oracle NoSQL Database, and we need also improve the Berkeley database, okay? So we can say that we are in the NoSQL spectrum since February 2006, because in this time, Oracle buys an open server company called Sleepycat, that is Berkeley DB, okay? That are some features that you can see here. We have from 2012 to 2016. That is the only thing that I can say about Oracle NoSQL Database. I can provide you some details because I am a new product manager. I start working in Oracle as a product manager in April, okay? So what I can do is, in order to provide a retrospective, is provide my own retrospective. Where I was in 2012, I was working in Oracle as a sales consultant, working in the big data. So my challenge was a new product, a new offer around NoSQL. So we have Hadoop, we have Oracle NoSQL Database. So for example, at this period, I start working with a customer in manufacturing. So we create an application in order to do time series analysis, okay? So this is very well designed in order to use a key value store, okay? So the main idea here is we have a problem that have a system and they have a lot of problems with scaling, a problem with response time, so latency. So the main idea is to build a new system around a NoSQL database solution. So we decided to do this. We did a proof of concept. So I think that the key value store was really adapted to this kind of usage, okay? So for example, in my case, the key is very easy, it's the sensor, it's the timestamp, and the value is just the information from the sensor, okay? So very easy, the key is very easy, the value is very easy. For your information, the value was a binary. So that is a network, okay? That's a network packet that I am storing in my NoSQL database. For example, this is in Big Indian. So my program is in Little Indian. So just before to send the data to the end user, I am just translating from Big Indian to Little Indian. So a first evolution that when you are working with this kind of database, it's okay, that's perfect. So the value, I am managing the value, I am responsible for this. But what about a deserialized process? This is why we add our schema, okay? So that is perfect, but though you are working and you have new uses. For example, in this case, one of the new uses is when you are doing a query, you are saying, I need the data in a time frame for some specific sensor. But in order to retrieve this information, you will look for an event, okay? So you are looking in log files, you are looking in metadata lists. So in this case, very soon you see that you need to have a new type of query. And in this case, you are thinking to have a secondary indexes, you are thinking to have a full text search and things like that. Another thing that is happening in the key value store is that you don't have a catalog. I think that is the same thing when I start working with Hadoop. HDFS is very good, MapReduce is very good, Spark is very good, but Hash Catalog is just amazing because that's allowed to manage the data. You have a data governance to manage the security. That's we'll call tables. The main idea is to provide a catalog, okay? Please don't think about tables as in a relational system. For example, just to say, for example, think the tables, think as you are grouping some data that have the same characteristics. For example, in this case, you can create a table called fruits, and you can say, I have a field called object name, and the object name is apple, and the other, and I have a field where I am storing the data. That is an opaque data, for example, any as type. So you are storing data from apples and the data from orange. Okay, you are mixing apple and orange. That is not very good in a model entity relation, but that is good in NoSQL world. Things to stream topic key value. Okay, that is the main idea behind this. But when you have a wildcard type, for example, in this case, I am talking about any, you're start thinking to JSON. So instead of have any, you are thinking, okay, any, if I need a structure, I can create data types. If I'm thinking to have semi-structured data, I am thinking to JSON, I am thinking to any. So JSON for us is a wildcard type, okay? When you have this, you start thinking also about query language and things like that. So that is really important. Okay, so I will stop here. We have elastic options, so we have a lot of functions. So this is the main idea here. We have also a fully managed server. We are also working in multi-region tables, okay? What is my preferred features? Okay, my preferred feature is the cloud service and the simply multi-model that I am trying to present this, and I will be focused on the next slide about this. And the last topic for me is multi-region. The last feature that I want to highlight here is the memory footprint reduction. So this is just to say that we are clear obsession for the performance. So the performance for us is really important. So what about the licenses option? We have a community edition, as I said. So we are open source and we are copyright. So we are Apache 2. Just for information, in the previous version, we have a 0, so we were copyleft. So the question is about the community edition. We have also an enterprise edition, it's core-based licensing. And it is very similar to other open software vendors. So we call this an open core. So most of the features of the open core are free. So in community edition is open source. And some of the features, for example, security, streaming, multi-region table are closed source. And of course, all the integration with other Oracle products are also closed source. Okay, we have also a serverless fully managed cloud database. That is, we will pay for read units, write units, and gigabytes of storage. I will do a sum in the next slide. This is also available for the pay-as-you-go and the universal cloud credit model. We have also always free NoSQL database. This is only in a subset of OCI regions. So if you want to test, you can do it. We have also a cloud simulator and a version of we call Cable Light if you want your test in your own lab. Okay. We are also, our product is working in community hardware. We are also working in enterprise hardware and all sizes. We have, for example, customers using only one drive, and we have customer using servers with 12 drives and 12 drives of 10 terabytes, or we have customers mixing drivers. So for example, here I am providing an example with 12 small servers, and we have also customers using big servers, but only 3. But we can also mix. That is the sample of one of my customers, and we start working. The customer bought some servers with 12 disks and 4 terabytes each disk. 1 year later, they decide to add more and more and more data. So they decide to buy new servers, and the new server is 12 disk but 8 terabytes. So we have the same number. We have 2 times more the cores in the new server. So we're able to mix this. So that is really interesting for our customers. We can also deploy on-premise in private clouds and also in multi-cloud. So I am just showing here AWS Azure, As you can see, if you use the enterprise version, you need to respect the licenses. So you need to be in AWS and Azure. But if you want to use the community edition, just call us if you want to install this in other cloud providers. Okay. And finally, we have also a deployment model based on in our Oracle Cloud. So this is fully managed cloud services. That is completely native. Okay. So for example, for the security, we are using the IAM classic from the OCI. For example, we are integrated with events and things like that. This is the same code as the standard distribution. For example, I did an interesting demo using other products like chatbots. So if you are interested to see this demo, we can do a new meeting. What is important in a fully managed cloud services is we are responsible for all of this. Scaling, this is our problem. High availability, we are managing this. Backup recovery, we're managing it. Upgrades and patching, we're managing it. Software installation, we are managing. This is also why I am organized my presentation in this way. First, application development, and then architecture. Because in the cloud, you are responsible only for the application deployment and the application management, okay? As you can see here, I have some icons. So when you see here, this icon means that this is true for the on-premise and also for the cloud, okay? So when I am talking about this slide, this is true in the cloud, and it's the same thing in on-premise. When I am talking about the premise, I am talking about the software. As already said, you also can install our products in other cloud providers, okay? If the logo change is because I need to provide an example of things that you must do in on-premise, for example, that we are taking in charge in the cloud. So I will provide some details. The first discussion is the development flexibility. So I will provide this time, sorry, I will provide a definition on what does mean a table. A table is an ordered collection of record items. So each record has a table schema. As you can see here, we can mix, so we can have fixed schema and we have schemaless. So in this case, we are also using JSON, and is when we are retrieving the data and we are applying and schema on it, okay? We have also access to the data using the API. So API that is true for key value and table. So this is an API get, put, scan. So CRUD API. We have also an API based on SQL. That is not the standard SQL. That is a SQL designed for our Oracle NoSQL database with its rich access to JSON and more complex filtering. Okay, that is very important for us. The SQL interoperability between schemaless and fixed schema. So let me show you an example. So for example, in this case, I have the same data on the left and in the right. But in one case, I decide to do a data modeling using a fixed schema. And in the left side, I decide to do the same table, but using a schemaless methodology, okay? So as you can see here, I have the same primary key, but the content here is a record with last visit. Inside this record, I have a new record, demography, and I have also an integer inside and an enum, okay? Next, as you can see here, we have exactly the same query to find all visitors to my site in November who are males between 24 and 30 years age. So we have the same criteria here, and we have the same criteria here. As you can see here, I am doing a cast. That is not necessary in this case because I am clearly in the fixed schema. I am saying that this is a timestamp, okay? Why I'm doing this is to have the same SQL query to do the same query on the profile data. As you can see here, we have an asterisk. It means that if this value, if this JSON path doesn't exist in a document, I will generate a null instead on an error, okay? As you can see here, that is the same thing, but in this case, if, for example, age, you have a bad data, for example, you receive something that is not a number, we will ignore this data, okay? That is why we are saying this is a seamless multimodal, because we are trying to do exactly the same thing in the two cases. So what about data? For example, I said we have an API and we can able to do a put. One of the options that we have is put a JSON file. So in this case, as you can see here, when I put this value, first visit doesn't exist in the fixed schema, but when I put this data in the content, I will accept the content. When I put this data in this table at the right, I just ignore the first visit. Of course, I have an option to say I need to have the same exact match between the fields that I'm providing here and here. But we are really flexible on this. We have also predicates, we have also projection, we have also string functions. So what is interesting here is even we are talking about JSON, we have also supporting complex type. In this case, we are talking about maps. So in this case, I am asking for all maps where the key is in com. Of course, I can say also content demographic dot income. I have group by. And that is important. I have also a sequence aggregator. For example, if I am inside an array, I can say what is the average inside an array without doing a group by. What else? We have also the document observed. This is really interesting when you are managing JSON files. For example, here I'm just adding new elements to an array. That is really interesting when you are working with some key value store. You are retrieving all data, modifying the data, and putting the data. So that is really interesting in the new syntax. Okay. Again, we have also GeoJSON. We have also the ID generation. For example, that is really interesting because when we are in a key value model, you are able to do everything, but you, as developer, you are responsible to do everything. From indexing point of view, then we have simple scalar, we have non-scalar, we have composites, we have JSON and GeoJSON. Just a little focus here. As you can see here, I am saying that this is an integer, but I am also able to say I just want create an index on the SHIP2, and I am indexing everything inside the SHIP2. Okay, that is we call also untyped JSON index. We have also the possibility to have full text index. This is why I changed a little bit here. This is only available in the on-premise option, in the on-premise deployment. But what about our architecture? Okay, so we are working really in a shared nothing distributed system. So we will have a shard, we have multiple shards, we will apply a hash function. So every shard will be responsible for some data. Okay, inside each shard we have a replication, then we have a leader, and we have two replication or more replication. You can say I want to have 4, 5 replications. So in this case, we are trying to use an odd number. So for example, 3, 5, and not to use 2. Of course, 1 is good for test, not for production. And I will talk about what does mean fault containment zone. That is a feature that comes from the previous slide. That is for developers. So all the drivers are now using an HTTP proxy. This is important because in the previous version, this is the driver that is smart and are aware about the topology. For example, if you are in one shard, you are not aware that you are in a distributed system and you have other shards. So when you are doing a query, this is the drive that will contact all the shard in order to produce the good answer. Okay. Because of this, that means that they need to access to multiple ports. So that was a problem. So we decided to create an HTTP proxy and do the query using this HTTP proxy. And for firewall, that is interesting because we are using a standard HTTP, using standard ports for open the firewalls. So that is something that is also important because we are using the same thing in the cloud or on-premise. So if you develop in the cloud or if you develop on-premise, you are using exactly the same drivers. The only thing that changed is the connection, okay? For high availability, we have multiple options. For example, I have customers that saying I have 2 rooms. So we are able to do the replication between 2 rooms. So I have some customers that I am saying I have 2 data centers, so I am able to do this also. This is we call primary zones. We have also things that we call arbiters. Arbiter is when you have to do a decision between 3. That is not good. That is not a good idea. But when we are doing a replication between data center, most of the time you have 2. You don't have 3. So the arbiter is just a process that is here just in case of there is a problem in order to do a quorum, okay? We have also secondary zones, and this is the possibility to have some read-only replication in order to offload some queries. That is a feature that I love very well. We call this multi-region table. That is the possibility to create a replicate active database. So in each region, we will have a completely autonomous cluster. And for some tables, we will say, okay, if for this table, I will create this table in one region and in a second region. So, and this time, all the things about the replication is managed directly by Oracle NoSQL Database. We have 2 possibilities where we conflict resolution. So the first one is the last update, and the second one is a specific data type that we call CDRT, that means conflict-free replicated data type. I will provide an example to try to understand. For example, imagine that we have a database here in France, and we have another database in Switzerland, and we have a table about the number of attendees to this meeting. So I am updating here. For example, I am saying we have 20 attendees, and in Switzerland we have 80 attendees. In a normal replication, when we are trying to do the config, we will say, oh, that is the last update for, in this case, 20 or 80. But this is not the expected result. The expected result in our case is 100. Okay, so CRDT is a tip that allows only some kind of operation. So we can, in the database, we are able to guarantee that we are only incrementing or decrementing the value, and we are only setting a default value. In this way, we can share the delta between the region and not the final value. And we are able, when you are doing a select, to recreate the real value. For example, in our case, we will say in France, we have 20, that is the delta. In Switzerland, we have 18. And when someone asks what is the value for count, we will do the addition and provide the final results, okay? Sorry. So that is the main idea here. That is just a tip that I am providing. I will publish very soon a blog about this, okay? We have online Elastic expansion and contraction. What about CAP-TORM? So this is our thread. So we are trying to have consistent versus availability. Okay, so the main idea here is we will try to do the best to guarantee the consistency, but we are also do the best to have availability. Sorry, I have no more time, so I will go to my conclusion. Just before to stop, so concerning about the Oracle NoSQL Cloud Service, so you are paying for each table. So you are paying for table, you can have different capacity to serve different workloads. That is really interesting for people doing search back. For example, this is interesting to say, okay, this application is working on this table, so I will have a paper trove output for each table and not for a global database. So that is really interesting. Our customers are really satisfied with this. And this is my takeaway. So please read. I will not talk about this. So take the time to read. In the PDF, of course, you can have. That is our message today. Okay. So as I said in my abstract, I hope that I was able to answer and I will able to do this. Thanks for your time. And if there is some question, please.
So in the questions, I don't see any at the moment.
Sorry.
Questions, anyone? If not, I thank you very much for the presentation. Thanks a lot.
Thank you.
And we will do another break. So die letzte Pause und dann noch